In this video, we'll be looking at calculations, in particular, reacting masses. Now here's a few things to remember. We need to remind ourselves on how to calculate moles, and if you've forgotten how to do so, please look at our previous video. Don't forget you're always allowed a calculator, and this particular calculation is for higher and triple students only. Please remember to show all you're working out, as there's always going to be method marks for these calculations. Let's remind ourselves how to calculate moles. Now, with this example, we're told we have 10.2 grams of aluminium nitrate and we're required to work out the moles. So, first thing we're going to do is work out the MR, and we can use the periodic table, which is always provided in an exam. And then we just input the values into the formula, where 10.2 grams divided by 213 is going to give us 0.048 moles. Okay, one more example. Calculate the mass of aluminium nitrate in 0.6 moles. And again, we're going to start off by working out the MR. And in this case, we're going to rearrange the formula and make mass the subject, where we've got mass is 0.6 times 213 to give us 127.8 grams. Here's a few examples for you to try. Take the next 2 minutes to do these. If you're happy with this, skip ahead, and if you need more time, just pause the video. Here's the answers to those questions. Right, now that we've had a recap on calculating moles, here's an example on reacting masses. Calculate the mass of magnesium oxide produced when 6.5 grams of magnesium burns in excess oxygen. Now, you are sometimes required to write a balanced formula, but for the purpose of this tutorial video, I will provide them. We have 2 moles of magnesium reacting with oxygen to produce 2 moles of magnesium oxide. Now, the numbers in front of each of these formula represent the molar ratio, and I'll explain what they mean in a bit. Before we start looking at the calculation, we are always going to write down the following: mass, MR, mole, and ratio. And then we just input the values we've been given in the question. So starting off, I know I have 6.5 grams of magnesium. I need to calculate the mass of magnesium oxide. Now my next step, and the only thing I can really do at this point, is work out the MR. And I have a periodic table to help me with this. So the MR of magnesium is 24. and the MR of magnesium oxide is 40. The next thing I can do is work out mole, and the only thing I can work out mole of is that magnesium. So I do 6.5 grams divided by 24 to give me 0.27. Okay, now remember those molar ratios I mentioned earlier. This is where they come in handy. I have a 2:2 ratio between the magnesium and magnesium oxide. And if I simplify this, I have a 1:1 ratio. This simply means for each 1 lot of magnesium, I'm going to make 1 lot of magnesium oxide. So I have 0.27 moles of magnesium oxide also produced. And my final step here is to work out mass. To do that, I do 40 multiplied by 0.27 to give me a mass of 10.8 grams. And that there is my final answer. Right, let's have a look at another example. Calculate the mass of aluminium that can be produced from 68 grams of aluminium oxide. And again, we need our balanced formula for this reaction. We'll use the same layout as previous, and again start by inputting the values we've been given. I know I start off with 68 grams of aluminium oxide, and I need to work out the mass of aluminium. Now, I don't need to worry about that oxygen there because I've not been asked to do anything with it. My next step is to work out the MR. I have 102 for aluminium oxide and 27 for aluminium. The only thing I can now do is work out the mole of aluminium oxide, 0.67. Now, to work out the moles of aluminium, I need to look at my molar ratio, 2:4. And if we simplify this down, it's a 1:2 ratio. So for each 1 mole of aluminium oxide, I produce 2 moles of aluminium. So I'm going to have 1.33 moles of aluminium. And again, my final step here is to now multiply to give me my final answer of 36 grams of aluminium. Okay, here's one for you to try. Calculate the mass of magnesium chloride produced from 5 grams of magnesium. And again, here's the balanced formula for this reaction. Remember, use the same layout as previous, and take the next 2 minutes to work through this. If you need more time, pause the video, otherwise skip ahead if you finish early. Let's see how we've done. We'll start by inputting our known values. 5 grams of magnesium. I need to work out the mass of magnesium chloride. We know the MR of magnesium is 24, and we can work out the MR of magnesium chloride as 94. First thing I can do is work out the moles of magnesium, 5 over 24, to give me 0.21. And then the molar ratio between all of these are 1. So it's a 1-to-1 ratio, which means I'm also going to have 0.21 moles of magnesium chloride. And then our final step is to multiply to give us an answer of 19.6 grams of magnesium chloride. Okay, now that we've had some practice, here's a few more for you to try. Take the next 5 minutes to work through these. If you're happy with this, skip ahead, and if you need more time, just pause the video. Here's the answers to those questions. Right, let's summarize. Remember, you have to memorize this formula. It's not given to you in an exam. Only worry about what you've been asked. Sometimes they'll give you a long chemical formula. There's usually only 2 chemicals which you need for the calculation. Use the layout we've used in this entire video. It works every time. And lastly, if you're ever unsure in a calculation, work out the MR. It's almost always going to be worth some marks. Okay, that's it for this video. If you have any questions, leave them down below and I'll do my best to get back to you.